So now I'm going to discuss the next physical property of liquid, which is intermolecular forces. Let's decode this terminology. What is meant by inter? Inter means the forces that. I'm sorry. Now we can highlight it. Yeah. Intermolecular forces are forces that exist between two molecules. Forces between two molecules. Forces between forces between two molecules and it is responsible for the physical properties. Responsible for the physical properties. I'm sorry, I made a mistake in here. So wait. Okay, so this is responsible for the physical properties. However, it is weak. It is not strong, and it is weak. It is weak, and by providing the temperature, it usually breaks down. It is weak in nature. It is weak in nature. And by providing the temperature, it usually breaks down. Right? So, for example, this is the one molecule of water, while this is the other molecule of water. You can see this is one molecule of water. This is a one molecule of water. For example, now I can make it here as well. This is hydrogen. This is hydrogen. Okay, something like this. The structure is not maybe fine. Something like this. The structure usually is like this, but I'm only explaining the example here. The actual structure is something like this, which is bent, or this is the shape, or tetrahedral, which is a geometry. So this is something like this, and this is the other molecule of water, hydrogen and hydrogen. Okay, so the force of attraction exists. This is basically a hydrogen bonding, but I'm telling you, this oxygen attracts hydrogen, and this oxygen attracts the hydrogen. This oxygen attracts hydrogen, and which means that the force of attraction occur between them, but it's very weak in nature, due to which providing the temperature, it breaks down. Right. For example, this is one molecule of water. This is one molecule of water. The force of attraction between these two molecules is known as intermolecular forces. And the example of intermolecular forces is hydrogen bonding, van der Waals. Van der Waals forces include all the overall forces, but only molecular forces. But this is hydrogen dipole. Now I'm going to write again dipole. Now I'm using this sign. And then hydrogen bonding, dipole, London dispersion. And all these are the example of which force? Intermolecular forces. I can explain you with the help of one example as well, London forces and all that. These are the example of, for example, I have a container. Let's take the example of a container. Let's take it. This is a container. These are the molecules inside the container. Molecules. When I have, for example, the water molecules. Force of attraction acting between. I'm not making this perfectly, but there is a force of attraction acting between them and something like this. And when you provide them the temperature of 100 Celsius, the bond between them usually break down. The bond between them usually break down, and they get far apart from each other. So this is basically intermolecular forces, and it is weak and very weak in nature.